For our final example, we're going to have a bit more complicated algebra going on here in order to solve this, okay? We have an exponential equation on both sides. So converting into log form is going to be more difficult than normal. So we're actually not going to convert from exponential to log form right away. What we're going to do is we're going to take the logarithm of each side. So like we did when we were deriving the formula, we're just going to take the log of one side, and that's equal to the log of the other side. Okay, just like we can square root both sides of an equation, we can take the logarithm of both sides of the equation. Now, what's the purpose in doing that? Well, the purpose in doing that is that it allows us to apply properties of logs. I can now pull the exponent out in front as a coefficient and make this parentheses x plus 2, because the whole exponent needs to stay together to start off, times log 4 is equal to, and I can do the same thing on the other side. I can pull this out in front as well. So that gives me 2x minus 3 times log of 5. Okay? Now, log of 4 and log of 5 are numbers, but we want to leave them in their log notation because they're not pretty numbers. They're very long decimals, and we want to avoid rounding. So our next step here is going to be to go ahead and distribute. So we're going to do log 4 times 2 and log 4 times x. We're going to do log 5 times the negative 3 and log 5 times the 2x. Okay? So this is going to be x log 4 plus 2 log 4 is equal to 2x log 5 minus 3 log 5. Okay. Now, things are starting to get a little scary looking here. There's a lot of terms going along, a lot of variables, a lot of logs. Okay? But here's what I notice. There's an x right here, so this term has an x in it, and there's an x right here, so this term has an x in it. The other two terms don't have any x's involved, so I want to have the x terms on one side of the equation and the other terms on the other side. So I'm going to subtract 2x log 5 from both sides. Okay. I'm also going to move that 2 log 4 over, but I'm going to do this in two separate steps. Okay. So I'm going to have x log 4 minus 2x log 5 is equal to, oh no, not equal to, not yet. I still have that plus 2 log 4 over there. That's equal to negative 3 log 5. Okay. And now the next thing we want to do is we want to get rid of this term right here. We want that on the other side of the equation. We want to move that over there. So we're going to subtract 2 log 4 from both sides. Okay. Make sure you have that written down, so I'm going to move on to the next slide to do this next part. Okay, so now we're here. We have x log 4 minus 2x log 5 is equal to negative 3 log 5 minus 2 log 4. Okay, we're getting closer now because now we have the x's on one side and everything else on the other side. And as you can see here, I put the x's in red so that I can kind of see them a little bit more clearly. And when I have two terms that both have the same variable involved, I can GCF that variable out. So I'm going to write x times, and then inside I'm going to have log 4 minus 2 log 5. And that's still equal to negative 3 log 5 minus 2 log 4. Okay? The good news is that all we need to do now is just divide out what's in those parentheses, and then the x will be isolated. Okay? So we're going to go through and we're going to divide, and that's going to give us this. We're now going to have x is equal to negative 3 log 5. So I'm copying down the right-hand side of the equation. I'm copying this down over here. Negative 3 log 5 minus 2 log 4. And I'm going to divide it by the parentheses, this part right here. This is being divided over to the other side. So I'm dividing by log 4 minus 2 log 5. Okay? Now that's our exact value answer, as crazy as it looks. But we want to get the decimal approximation for this so that we can have a better sense of what the number is for x, okay? So our final answer here, we need to be really careful when it comes to parentheses, okay? So I'm going to show you there are naturally parentheses around every single log value, all right? But because the numerator is 2 terms, I also need parentheses around that before I hit the division, and because there's 2 terms in the denominator, I also need parentheses around that. So what you see here is what you have to type in. It's a big, complicated mess to get in the calculator. You need to be very careful with your parentheses, okay? But if you do that, you should end up with x is equal to 4.1476, okay? Make sure you can get that value out of your calculator. If you can't, you need to let me know, all right? So that's it. That is going through and solving that final problem. Good luck with your homework.